All right, let's have a look at practice question set number 9 in preparation for quiz number 9 tomorrow, of course. Question number 1 says, Newton's law of universal gravitation has a mathematical relationship similar to the one developed by, yep, it's going to be A, Coulomb, right? You don't know anything about Einstein yet. You're going to learn some stuff about Einstein this year, but there's nothing that's remotely close to Newton's law of universal gravitation. Lenz, again, you're going to learn something about Lenz this year, but he has nothing that's remotely close to that. Ohm, you don't learn anything about Ohm this year. You did when you were in grade 9. Okay, so you might recognize the name, or you might not remember. That's okay if you don't. But it illustrates a good point. Okay? If you don't recognize a name, if it's not something that we've done in Physics 30, then it's not the answer. Right? Even at the end of the course, if you saw this question, you'll recognize Einstein and Lenz. They're not the answer, but at least it's conceivable that you could pick either B or C by the end of the course. You would never pick D, even at the end of the course, because you won't have done anything with Ohm this semester. So it applies to this question, applies to a number of questions, right? If we see something that we don't recognize, it's not the answer. Don't pick it because it sounds like, Ohm, I don't remember that one. It must be the answer. Like, no. Like, you pick the one that you remember, not the one that you don't remember. All right, number 2 says, which of the following graphs represents the relationship that Coulomb determined between the force and the distance that separates the two charged metal spheres? Which one's it going to be? D, yeah. In fact, it's a F is related to 1 over R squared relationship. If we wanted to straighten that graph, so that we could analyze it in the way that we typically analyze graphs, what would we have to plot? Not F versus R, because F versus R gives me a curved line. Yeah?
F versus 1 over R squared.
Good. F versus 1 over R squared would give me a straight line, and then I could deal with it the way that I deal with things. That's what you did on your lab, right? Is you ended up taking this first graph right here and converting it to an F versus 1 over R squared graph so you could find the slope of it and then do your thing with the slope of it. Good. Next question. The magnitude of the electric force on an alpha particle that's this far away from an electron is what? Okay, very straightforward one here. KQ1, Q2 over R squared. We just got to recognize that Q1 is a charge of an alpha particle, 3.2 times 10 to the minus 19 coulombs, or 2 times the elementary charge on your data sheet. And this is 1.6 times 10 to the minus 19 coulombs. And of course, R is 4 times 10 to the minus 10 meters. Make sure you can do that. Make sure you can do the math and get the right answer there. Also remember that it doesn't really matter what order you put those charges in. You put the electron first versus the alpha particle. It doesn't really matter. When you do the math there, it works out to be D, 2.9 times 10 to the minus 9 newtons. And number 4, it says Coulomb started with 2 identically charged spheres separated by a distance R. The force between the spheres was F. Then he changed the separation to 2/3 of what it was before. What's the force on the sphere become? That's a question we haven't seen in a while now. We called that variable value changing back in the first unit, right? We did it with P is equal to M times V. That's an easier equation to deal with variable value changing because there's no squares involved. But the same technique that we applied then is what we're going to apply here now. We just have to be careful of 2 really important things here, and I'll show you what that is. Okay, just a reminder here, we're going to say the original force is KQ1, Q2 over R squared. Okay, we don't know what the value of the original force is. That's okay. We know the equation is KQ1, Q2 over R squared. My new force, after I make my changes to it, is K times, well, we're not changing the values of Q1 or Q2, but we are changing R. Now remember, we're changing not R per se, but we're changing the separation distance per se. This equation says KQ1, Q2 over separation distance squared. If we're squaring the old separation distance, then we have to square the new separation distance as well. So make sure that you don't say 2/3 R squared. Make sure that you say brackets 2/3 R squared, because you got to square everything, right? Now let's simplify this a little bit. We get K times Q1 times Q2 over 2/3 squared is 4 over 9. Right? Does that make sense? Squaring everything inside the brackets. And then well, how do you divide by 4 over 9? Sorry? Yeah, multiply by the inverse or by the reciprocal, so it becomes 9 over 4 times kq1, q2 over r squared. And this is my original force. Right? This is what I started with, kq1, q2 over r squared. So my new force becomes 9 over 4 times my original force, which means the answer for this one is D.